Hello, everyone, and welcome to my presentation on our paper called No-Code Shadow Things Deployment for the IoT. I am Ege Korkan and from Technical University of Munich, and I will dive in right away. I will first most say that Internet of Things, one of its principal goals has been achieved thanks to many of us here, and which is basically connecting constrained or not devices to the internet. And this has been achieved through different means, such as non-IP level protocols like Zigbee, Bluetooth, Sigfox, and LoRaWAN, or IP level protocols through more conventional routers to the internet. However, once we start thinking about building systems of devices, in a way cross-system applications, meaning that we want to connect devices that are from different systems and build applications of them, this gets quite tricky. And we have actually a huge interoperability problem. So these systems are mostly not interoperable. This is due to the fact that there are different frameworks, different protocols on top of other protocols, or cloud providers who lock in the devices. And actually, if you look into the word internet, so the state of internet in its infancy was very similar, where there was an interoperability problem. But this has been mostly fixed, and we don't talk about it that much anymore. And this is also due to, thanks to partly to the web, which allows us to build applications on the internet. And basically, if we look into a website, which is a good example of a web application, we see that it could contain different services. So for a hotel booking website, we could have payment through one provider, map information through another. We can have weather information. And basically, this is what we used to call web mashups. And they're still called web mashups. And basically, what is missing in Internet of Things is doing this in a similar way through different IoT systems. And basically, this is what is called the Web of Things. And in a way, it is very similar to what web is for internet. And Web of Things was coined around 2008. And basically, the concept was to interact with devices over the internet in a very similar way to interacting with web APIs. And in this case, we could imagine an endpoint of an API or a start page of a website having sensors and actuators shown as resources which can be interacted via different protocols. And a lot has happened since then, and now Web of Things is being standardized by the W3C, so the World Wide Web Consortium. And the group who is doing this is the Web of Things Working Group. And the Web of Things Working Group has different standards and documents that they're working on. And most notably, the architecture and thing description have been published as recommendations as of April 2020. And there are supporting deliverables such as scripting API binding templates, and very recently the discovery that the group is working on. This group is composed of many companies which are of different backgrounds, like industrial, device manufacturers, network providers, cloud providers, and so on. And we also recently got new members, and the group is growing, and there's actually a lot more companies who are contributing. The Web of Things architecture specification actually talks about the different use cases, and then specifies what we call interaction affordances and the Web of Things operations. So what we mean by interaction affordances are categorized into three: so property, action, and event. And they are basically what a thing offers to its consumers to interact with it. So let's see some examples. So for properties, we can imagine that a consumer, which is what interacts with a thing, would then, for example, read the rotation speed of a ventilator, and then the thing would respond. And then we say that we have read property and write property operations. We can also observe properties and unobserve them. And in a similar way with actions, we can invoke them. So we can ask the thing, which is the ventilator, to rotate, and it might respond, and we call it invoking an action. And lastly, events, which is very self-explanatory. A consumer can subscribe to events, and a thing in an asynchronous fashion can notify the consumers. And then here we call subscribing and unsubscribing from events. And all these things are found actually in a thing description document. So this is a small thing description document which contains actually all the technologies that are relevant for this paper, where we can see that it contains some human-readable metadata, the security schemes that are needed in this thing, its base URI and the protocol that it uses. And then basically on the right, which is the most important part, we see the different interaction affordances. So we can read the rotation speed, we can rotate it. We can have an emergency button that delivers a Boolean. And then here we actually see that it can use a different protocol. So we are not bound to a specific protocol. We can mix them and have things composed of different protocols. And as you can see, for properties, we can have data schemas that are, which is describing the data that is being delivered, and similarly for the actions, what can be provided and what the thing can respond with. In a way, we can summarize it just as like this. So a thing in the Web of Things has a thing description that it exposes to the outside, to its consumers, and the layers of the thing would then be composed of different protocols, a certain payload that is being delivered through these protocols, and then internally it would have some sort of a logic or a state machine that is responsible of finding the correct payloads. In thing description, we abstract the layer A, and it's one of its design goals. It's to abstract this. And however, when we are working with the Web of Things devices and are building systems with them, we see that there's a lack of automation when we want to create virtual instances. Basically, when we want to simulate things so that we can program our control logic over different devices, we see that most simulations are created manually. And in case there is an automatic solution, they are always protocol specific, which is not the case for Web of Things. And also we see that basically once we want to enhance existing things, which can very easily be whose source code cannot be modified, we basically want to avoid the resource constraints, which limits the device to be scaled to the internet scale. We want to be able to change the protocols of the thing. So basically map it to other protocols such that it is compatible with different consumers. And it could also be the case that the thing comes without a security mechanism or with an incompatible security mechanism for a consumer, and we would also want to enhance or change this. To remedy these problems, we are proposing the shadow thing method. A shadow thing is basically a thing that sits between the physical thing and its consumers. And it is deployed based on the TD of the physical thing. And additionally, a configuration file helps it to be adapted to different cases, such as during development for simulation, during runtime to support the device, for scalability, and so on. And in the end, we provide different use cases which demonstrate the use of shadow thing and evaluate it. The shadow thing method can be detailed in this figure, where the layer A of a thing is can be expanded into different layers via different configurations. We will go into each of these in a minute, But basically, we could also see that on the left-hand side, we would always have a certain protocol, let's say protocol A, and on the right-hand side, we would have another protocol for all the different cases. So for a simulation, we could have a TD that uses one protocol, and its simulated version could be another protocol. The proxying can happen through different protocols, and so on. To make it more concrete, the Shadow Thing is implemented as a software package in Node.js runtime, and it's called Shadow Thing. It's available already in this URI for you to download and experiment with it. And importantly, it is based on the Node.wat library of the Eclipse ThingWeb project, which gives the thing description support and different protocols. So let's start with the first one, the simulation. So for the simulation aspect of the Shadow Thing, we are starting with a TD without a physical device that is present. Based on the TD, we can choose the protocols, and since TD has the information on the payload can be automatically generated from the TD. Additionally, if the developer wants to provide a more concrete behavior of the thing, it is also possible, such as, for example, describing how the temperature evolves. But out of the box, the Shadow Thing is able to work without any developer effort, just with a TD that already exists. Then we evaluated the simulation side of Shadow Thing on this following hardware and software. And we basically see that we can simulate a very large number of things. For example, for a typical developer setup, the developer laptop setup, we can very easily simulate 1 million things, which can all respond to requests and emit events under 2 minutes. And we also see that the deviation is very low, meaning that it's very deterministic in the way it works, and there is nothing blocking them other than the hardware. And we also see that we can, for more research purposes, for example, we can simulate up to 32 million devices in this configuration, and again, with a low deviation. And we would also like to note that for researchers who are working on Web of Things, for example, to test how their discovery method scales, they can use the simulation method to deploy a very large number of devices and test the scalability of their method. Then we have the scalability support. This is basically in the case where we deploy the Shadow Thing with the physical device, where the data of the device can be cached with a certain caching interval. And this allows it to scale to a high number of consumers, and basically, again, allows to deploy this instance automatically. In this case, only the caching interval needs to be given. And again, only the TD and the caching interval is enough. And we evaluated this again, and in this case, we had an ESP-based light sensor that had light intensity as a property affordance, and we chose a device with more resources, such as the Raspberry Pi with the gigabyte of RAM, where the Shadow Thing actually runs. And this is again deployed automatically from the TD just with the caching interval. And then we have a computer who can simulate an increasing amount of consumers who can either send the read property requests to the ESP or to the Raspberry. And basically, we see that for the case of the physical device, the ESP, after 5 clients, the time starts deteriorating significantly. And at 20 devices, basically, the program starts crashing. And also the deviation increases significantly. And in the case of Shadow Thing, of course, we have a higher time to read, since there is an actual communication happening with this physical device. But as soon as the amount of consumers increase, we can scale much easier since we have more resources. And lastly, we have used the Shadow Thing in a case study where we want to change first the security of security mechanism of a physical device. So here like on the left, you see that there is no security, and on the right there is. And we also can use it to validate the payloads of the physical thing in case it is it's not programmed to detect this malicious behavior. And basically, in this concrete case study, we had a thing with CoAP protocol where we initialize the shadow thing by configuring the security, the address to fetch the TD, and the protocol that we want. In this case, we had a consumer, which is a browser who can use only HTTP. And after the configuration, the shadow thing boots itself, and a consumer can use the HTTP protocol where it has to supply a certain security mechanism. In this case, it was basic authentication. And as you can see, the shadow thing communicates with the device which comes with no security over CoAP. And also, lastly, very importantly, we can also validate the input provided by the consumer. In the case of a negative speed, we can also directly reject the payload without ever communicating with the device. So this was the last use case, and I would like to then conclude by saying that the shadow thing, as the core method, creates virtual instances of IoT devices in the Web of Things context. It is very easy to deploy since the TD of the device already exists. It can be used to create a simulation, a smart proxy, and the device adapter at the same time if needed. And in one sentence, the shadow thing enables scalable, reliable, and safe IoT devices by adding a layer between the thing and its consumer. Then I would like to finish by listing the references we have. And here is my contact information for any questions later on. And thank you very, very much for listening to this presentation.